Good. Good morning, everybody. If you're standing in the back, there's plenty of seats here up in the middle. Just raise your hand if you got an empty seat by you. So we're in this nice, shiny new venue where folks don't have to sit in another room watching a live stream of the keynote. So please take advantage of those seats. How are you guys all liking Pasadena this year? Cool. Well, I'm glad you guys are liking our new home. Pasadena has been very welcoming to the SCaLE team, and one of the folks that has been doing that we've been working with is Andy Wilson on the city council here, and so I'd like to call him up. He's going to be introducing our session today. And for Andy Wilson.
Good morning. Good morning. I'm impressed this group is up at 10 o'clock in the morning on a Saturday. I had my coffee, walked my dog, so I'm ready to roll. First of all, thank you and welcome SCaLE 14X. I wanted to tell a little story about how this happened because, first of all, having you guys in Pasadena is incredible, and it doesn't happen by accident. So I'm going to follow my notes here because my coffee hasn't fully kicked in. But I remember Richard Gatson is sitting up front, and Maddie came to me and said, "This thing SCaLE is awesome, and it needs to be in Pasadena." And then they wanted my help. And I said, why are you talking to me? And you're probably like, why is Andy on the stage this morning? Besides being on my walking ride, I had a few things I want to say to you. So I co-founded something called Innovate Pasadena. Is anyone familiar with Innovate Pasadena? Any people? We got a few, yes, thank you guys. And that's all about creating a vibrant tech ecosystems in this part of Los Angeles. So I'm going to talk about that a little bit later. And that effort, Innovate Pasadena, is more around technology and engineering, a little bit different than I think the consumer media activity in Silicon Beach. So if you're really kind of nerdy like me, we're trying to make this home. So that's our focus with Innovate Pasadena. I also have started a series of software companies and invested in a bunch of companies. And as Alon mentioned, some people say I drew the short straw. I sit on the City Council of Pasadena, and I'm really the advocate for innovation in technology in our city. So I've been a startup geek, and I'd heard of SCaLE, but I didn't know a lot about it. So they were educating me, and I started to learn that SCaLE is the preeminent event for Linux users, attracting more than 3,000 people. Are we close to that number, Alon, this year? Oh, more. Awesome. So 3,000 amazing people. Great job. And I like to say, bringing together the best and the brightest. So welcome. And who cannot like Linux, right? My 9-year-old is a coder. He likes to hack, particularly on Minecraft, especially when it's time to do his homework. And I was telling my kids about Linux, and my 9-year-old says, "Isn't that the thing with the penguin?" And I don't know. I think we're always going to think it's a penguin thing. And who could not love penguins? There's a book called 365 Penguins that my kids made me read when they were young. And ironically, penguin birthday parties were all the rage when my kids were younger. So I hate when people talk about their kids, so I won't talk about my kids anymore. I did research on penguins so I could talk to you guys with some credibility. And they're pretty incredible animals, apparently. Very social. I have a feeling this group is social. We're going to check the box there. But also considered one of the smartest animals in the world. So I think Linus was pretty bright in choosing the penguin. So why is the Linux SCaLE conference a great fit for Pasadena, right? And it's great you're using, kind of filling this building. By the way, I served on the board of the convention center when we built this beautiful building, so I'm glad you're taking advantage of it. But let me tell you a little bit about Pasadena. And I'm going to brag because I want you to know about Pasadena so you come back and realize what we have here. Okay, we're a city of 140,000 people. I think you used to do this in Long Beach, am I right? So LAX, okay, LAX. Okay, not that great, but Santa Monica has less. They're about 90,000 people, so we're a little bit bigger than Santa Monica. And we have a lot of great stuff in Pasadena. Mars Rover, up the street, JPL. Any JPL people? Go JPL. There was a video they did called, I think, 5 Minutes of Terror about the landing of the rover, which is incredible. DNA sequencer spun up out of Caltech. So if you think understanding the human genome is important, that came from Pasadena. CMOS semiconductors, Caltech invention, unbelievable. Maybe some other things that are more relevant. Paid search advertising, invented and patented. Company I work for out of Idealab called Overture Services invented paid search. We all know that is the monetization engine behind Google. I think it worked out okay for them. A couple other companies hatched in Pasadena. eHarmony moved actually to Santa Monica, won't mention that. Earthlink City Search, and more recently, incredible companies. OpenX, do we have any people here from OpenX? Yeah, we got some OpenXers, good. Spokio, incredible company around data and people search. SupplyFrame, also here as well. So just to mention a few companies in Pasadena. Caltech and Idealab. People familiar with Idealab? Raise your hand if you know about Idealab. So Idealab was the original incubator. 140 companies came out of Idealab. Now incubators are kind of like everyone has an incubator, but the first incubator was in Caltech, run by a guy named Bill Gross. Caltech, 30 Nobel Prizes, right? We got some smart people at Caltech. Gosh, they're amazing. So a lot of incredible people. We're talking tech, Art Center College of Design. How important is design to technology, guys? Come on. Art Center College of Design in Pasadena. We know if you can't get people to understand and use your technology, it's not worth very much. So having people think about industrial design, usability, Art Center here is in Pasadena. They do incredible work. Interesting fact about Art Center. The majority of the cars on the road today were created by an Art Center hand. So you think about the impact to an industry, Art Center designers are extraordinary. We attract almost $2 billion annually in R&D funding in Pasadena. That's $14,000 per capita, more than any other innovation hub in the country. So lots of R&D dollars going here. We're home to 3 of the top world's engineering firms. Dare I go on and boring you, so I'll stop. Anyway, so the bottom line about Pasadena, like me, we love smart, nerdy people. This is such a great place. My kid tells me I'm a nerd, and I said, thank you for the compliment. So a little bit about Innovate Pasadena, because I think it's a personal mission. It's an organization that I helped found, and I want to share with you what we're doing, because I think the SCaLE mission is very consistent with that. So 3 years ago, I helped found a local grassroots organization focused on building our local kind of geek and tech community called Innovate Pasadena. And our vision, and bear with me, is to create a vibrant ecosystem of technology, design, and innovation in greater Pasadena that supports sustainable growth. I'm not exactly sure what that means, but it sounds impressive. But I think the bottom line is we are here to help connect people, right? Connect people with other innovators so they can strengthen the innovation community, right? And build more great shit. It says like we help people build more great shit. Because we know by connecting people and sharing ideas, that's where innovation happens, right? And clearly conferences like this are super important to what we're doing. So connectivity is key, and supporting conferences like SCaLE plays right into our kind of sweet spot. So to wrap up, I did a little research on Mark, who I met briefly, who's an incredible guy. I was reading about Ubuntu and Unity Desktop, and you guys probably know what that means. And I found out that he was an early adopter, and he and I were talking about this early, to space tourism, right? Space tourism. I don't know if I can say it, but he paid some $20 million to go to space. I'm thinking maybe someday I'll go to space. And with companies like Virgin Galactic, SpaceX, Blue Origin, all of us, I think, will have some time in our lifetimes to actually experience space, and hopefully not at $20 million, but 2 orders of magnitude less than that. So, your fantasies can become reality thanks to innovation and technology. And I was reading about the genesis of Ubuntu, and it says it means, I think if I get this right correctly, humanity towards others, or the belief in a universal bond of sharing that connects all humanity. And I think our mission at Innovate Pasadena, and I think for innovators in a whole, is around community building and sharing ideas and connectivity. So I'm really happy to have you all here to help you facilitate your community, because I think what you're doing at SCaLE in the Linux open source movement is very consistent with what our ethos is around creating an innovation community here in Pasadena. So thank you for coming, Alon. Thank you for having a great conference. Thank you for letting me bore people first thing in the morning on Saturday. I wish you all a fantastic rest of your conference, and I have fingers crossed that this is the first of many times we get to host first this group and many like yours. Richard wanted me to mention April 11th and 12th we are hosting the Worldwide Space Apps Challenge, which is a hackathon around the space data set, right? 100 concurrent locations, hacking space data around the world. We've moved that kind of ground zero of that hackathon from New York to Pasadena. So I hope you'll be involved in that. I'm going to turn this over to, I don't know, Alon, Mark, who's next? Mark, Alon? Someone more impressive than me. Okay, guys, thanks very much. Have a great conference.
Very nicely done. Doof, doof. Hello. Balancing out. Down, up, down. This is fun. Is that...
I've got it over here and it's off.
All right. Technology, huh? I think we're good. All right. Well, what a treat to be here loudly in Pasadena. The reason I'm into this stuff is because technology changes lives. And technology changes lives in many more ways than you think. You know, we think that society evolves because people decide that they want something different. But actually, society evolves because it becomes possible to live differently, right? And then we embrace what's possible, right? And what's possible changes because of technology. So one of the reasons Ubuntu exists is because it struck me that there was this enormous potential for innovation around free software, but there was also enormous friction, right? I looked in the late 90s around the technology community, and there was this huge divide between the people who had access and could easily consume this amazing free software, and those who couldn't just because it was too difficult or too foreign or too unusable for them. And Ubuntu initially kind of came into being because I thought, and I was lucky enough that lots and lots of other people joined in with this vision, that if we could make that free platform easily consumable, then amazing things would happen, right? People would build new kinds of businesses, they would get deeper into new kinds of data, new kinds of science. And so the happiest thing that happens to me all over the world is people come up and they say, thank you very much, Ubuntu changed my life. It made it possible for me to do things that otherwise I wouldn't have been able to do. And obviously it's not Ubuntu, it's that huge tail of free software, but we did something we tried hard to make that consumable and easily accessible. Now, Ilan set me a challenge to talk this morning about free software in the age of app stores. And that's a super interesting topic because I think it's something we could easily forget, right? The nature of software itself has changed a little, right? If you think back to the 90s, software was scarce. You know, there was a price on software, and that price either took the form of, you know, a cash, which is an obstacle. I grew up in a country very, very far away from the epicenter of technology, and I couldn't afford software. I remember saving for a year so that I could buy Smalltalk. Right? I was fascinated by Smalltalk, and that took a year for me to be able to get it. And then I found myself in a position to say, well, we could actually just make that great software, the best software that people make in the world, we could make that easily and instantly available, so nobody has to wait a year just because they happen to live somewhere where, you know, currencies work against them. So software used to be scarce. And free software has essentially changed that. Now, today, we have vastly more software, vastly more complex software, and software that moves much faster than ever before. So if I look at the sort of world of software today in this App Store era in a really interesting way, 6 months, which used to be a really fast cadence of releases, of getting the new stuff out to people, 6 months is way too slow, right? If I look at the really cutting-edge stuff that's getting done now, the stuff that I would like to accelerate and help, sort of robotics, people making robots that can help people live better, people figuring out how to introduce smart devices into the world, people doing stuff on the cloud, only about half the stuff that they need is stuff that we can curate at the speed of a distribution, right? The other half of the stuff is stuff that's happening on GitHub, right? It's happening at the speed of Git, right? And so in a very interesting way, one of the things that's changed as we move into this era of app stores is just the speed and complexity of software has kind of leveled up. And that happens slowly, so like the frog in the pot of boiling water, right? You may not be aware of that change, it just kind of happens. But think for yourself, how much of what you do on the cloud involves apt-get or yum or something like that, where you're getting curated software from a distro versus building the latest version of something from upstream, from GitHub or from somewhere else. So this is one of the areas that I've been thinking about a lot, right? How can we understand this new sort of speed of software, and how can we support that from the perspective of a distro? And essentially, if you think about the role of the distro, it is about essentially taking on common work, integration work, to make sure that two pieces of software kind of fit together and work well together. You can get them on, get them off. Trust work, looking over the code, patching it to address security issues, maintenance work, right? Making sure that that stuff can just become a background utility for people. The fact that we move that into the background allows bright people to apply more of their intelligence to solving the problems of society and the problems of the future. But there is a trade there, right? It takes time. It takes time. That's why it takes us 6 months to produce a rev of the distro, 2 years between LTSs. So we looked at how we could potentially, in the age of the App Store, do this differently. And the heart of the problem is this. In a traditional Linux or Windows or Mac OS type environment, all software is the same, right? We treat every piece of software exactly the same. Every piece of software, when it's installed, effectively has root, right? And not just root here, but root everywhere. So you install a package, and that's great. You can apt-get it, you can apt-get remove it. You install another one, that's great. You install more. And because each of these packages can do anything on the system, what you end up with is a fairly complex story, right? And it becomes difficult to know exactly what you've got, right? You know because you did it once. But if there was 100,000 of them out there in the world, it becomes difficult to reason about all of those different things. And that complex interweaving of software really makes sense for a lot of the sort of deep common stuff that we all use, like GCC, the foundational stuff. But it doesn't necessarily make sense for the things that we're talking about now, the stuff that moves really fast on GitHub, right? That stuff is kind of a leaf node rather than the web in the middle. So we looked at that and we said, well, how can we change that? How can we change that trade of speed for trust, integration, and maintenance? And so we said, well, let's look at two of those things. Let's look at the nature of trust on software, right? And let's look at the nature of integration on software. Now, trust is really important because in a traditional world, those packages are going to can do whatever they like, right? So when you apt-get install something, that package can literally do whatever it likes, right? So we have to figure out ways to trust it. But what if we could put it in a box, right? What if we could put each piece of software in a box and say, like, that piece of software can only go so far. I can only see the stuff that I give it in its box, and it can only write in places inside its box unless I explicitly let it write somewhere else. And this is really interesting. There's a great paper called A Machine for Keeping Secrets that I read, and it was talking about how, in a sense, we get it wrong. Today, we still live in a world where we think that the software is working for us, but increasingly the software actually is half working for the guy who wrote it, right? Think about that. The software is half working for you. You're installing it. It's your machine. But it's also kind of half working for the person who wrote it. And so it becomes interesting when you see that to sort of say, well, what if we could create like a DMZ on the machine? And we could say, right, in there I trust that person with the stuff that I give that software, right? But I don't trust it with anything else. So that was the genesis of something called Snappy, which you might have heard of, right? And it's a new packaging system that I think is going to match GitHub for binaries, right? It's going to be software at the speed of GitHub with the convenience of apt-get, right? Lots of people will use it just for their own stuff, and lots of people will use it to share things in the way that perhaps they use PPAs to share stuff today, if you want to create a package that's shared. So how does it work? Well, the first thing we do is we say we segregate the system using some of the new kernel primitives for isolation and confinement. And we segregate the system into blobs of software where it's absolutely clear and unquestionable who's responsible for each blob, right? So let's take a tour of that system. There's a blob there which represents the OS. And that can be updated essentially arbitrarily on any given day by the people who make the OS. There's another blob that represents the kernel, or the hardware effectively. And that can be updated essentially arbitrarily by the people who make the kernel. And again, we keep all of the files from those blobs separate. So in fact, the code sits in a read-only blob. It is literally a single file on a file system, and it never gets unpacked. That's really important because it lets us digitally sign it, and in an era where there are some very smart people who devote their time and attention to compromising the integrity of our computing, I'd like to live in a world where I can check signatures on software every day at boot time. So we built that world, and this is what it looks like, right? All of the code associated with the hardware in one blob. That has some space that it can write to, some read-write space. But you can imagine that if you just deleted the data in that read-write space, you'd effectively have reset that aspect of your computer, right? Similarly, all of the entire operating system in one blob, right, with some read-write space where it can store configuration or data associated with that. And then apps go into boxes, right? Apps become blobs, single files, compressed with everything that they depend on, and they get the ability to write to space that is assigned to them that no one else can write to. And so we're starting to just change the pattern of trust. No longer when you install software are you trusting that person who wrote that software with every bit of data on your machine. You're only trusting it for the data that you feed to it. And that, I think, fits the modern era of app stores much better. If you think of what changed in personal computing with the advent of the App Store, we now consume software from many more companies, right? I think that's fantastic, right? But we correspondingly have less recourse, effectively, less idea of who wrote that software, what are their motivations, what are their intentions, how do I find them, right? So in a world where it's impossible to sort of to square that circle, you can't have perfect knowledge about huge numbers of actors, right? But if you can essentially put stuff in a box, then you don't have to worry about it so much more. So this is the kind of Linux equivalent of saying, like, when I download a game onto my phone, I don't want it to read my address book, right? And I don't want it to have access to the microphone. Now, partially we did this because there's a whole new world of computing opening up. And in the free software community, we have a bad habit of waiting for larger proprietary companies to invent stuff and then essentially trying to commoditize that. But it means that in many cases we've played kind of second fiddle. We've come to the party long after the rules of the game got established. And I think that what's really exciting is that for the first time, actually maybe the second time, free software might be there right at the beginning of this whole new phase of computing. So what does it look like? And again, the things we were trying to address here, we're trying to reduce the amount of work required for somebody to publish software. Essentially the work required to package software. Whoever's tried to package software in deb or RPM format? A couple of people, right? There's a fair amount of work to be done, right? There are a lot of rules. And the reason for those rules, of course, is that those rules help all of those pieces of software that can do anything not tread on each other's toes. Well, because we've put each piece of software in a box, effectively, there are far fewer rules. You can basically do whatever you like in that box, right? So this is what a package looks like. Maybe difficult to read, but the summary is super clean, super simple. This is a package that's basically pulling two pieces of software, GPS, D, and NTP, and putting them into a snap, essentially a big blob, so that they can be installed and removed together transactionally. And the reason for that is I'm a bit of a clock freak, and this will let me use GPS to run really accurate clocks in the house. So what does that feel like in practice? That's that package declaration. So that's describing a snap, and you may be able to see that it's composed of two parts. And the reason for that, there's one part essentially saying, here's how you fetch and build GPS-D, and there's another part saying, here's how you fetch and build NTP. Now, this is a packaging system, not a build system, right? The way it works is essentially it's describing those two parts, saying the one uses scones and the other uses auto tools. So we're essentially just documenting in a structured format what you would do if you were surfing through GitHub and reading READMEs and building stuff, right? You'd say, here are some dependency packages that I want to have installed in advance. I'm going to use makefiles, or I'm going to use autoconf, and then just do what you would normally do. We all know those patterns. We all do it fairly sort of quickly without thinking. This is essentially just a structured way to describe it. The net effect of that is if I say snapcraft build or snap, it will go out and fetch, if I still have my VPN running. So it went out and fetched the code for GPS, went out and fetched the code for NTP. It checked that it had packages up to date and installed, and now it's just going to build. So this is a from source build, and the reason that's important is because this code that moves faster than the distro can move is source code, right? That's the great thing about the world we live in right now. It's coming straight from GitHub, and it's being built from source. So of course, there's a different kind of trust game going on here, because this code is never going to go through a distro. Like if you installed one of these snaps, it would be coming literally from the person who built it. So we're bypassing, in a very real way, we're bypassing some of the traditional trust mechanisms. That's why we've got to put it in a box, and that's why we've essentially got to create a more direct relationship between the user and the system. I'm running a VM, which is a snappy VM, and if I say, I can't use apt-get, right? Why? Because again, this is a system where there's no read-write file system, right? This is a set of snaps. So what can I do? I can say, what snaps are installed here? And those are those kind of base snaps that I was describing, right? Each of those is a single file. If you actually looked at the file system, you'd see 3 blobs effectively that contain all of the data for the kernel, what we call the gadget, and the OS. I don't know if there are any updates. Maybe something came in overnight. Nope. One of the advantages we get here is that updates become super fast, because you don't have to fetch a whole catalog of all the snaps effectively. It's just a single message up saying these are the snaps I've got installed, and a single message back saying you might want to try these ones instead. And I previously built that snap, and so I can install it just like that, and you'll see Snappy there. So we've got this kind of prickly file system. It feels a lot like firmware, if you've ever kind of gone into a firmware world. And in fact, that's the sort of spirit that we're going for. Occasionally, that gets uncomfortable. So one of the things we've added now is something called the classic dimension. So a snappy system has this kind of rigid file system that's really nice for if you've got thousands of them out there, because you know exactly what they're doing. But it's a bit uncomfortable if that's a machine that you happen to be logged in. So what we do is, again, using some of the modern primitives, we create this classic dimension. So you've got the snappy system with its snappy file system, and we essentially create a container, a special container, which has a traditional deb-based file system. So now, here, apt-get works just fine. And so you think of it as one system with 2 faces, 2 dimensions, right? And if you pop into the classic dimension, you can use apt-get. You have all of those tools available to you. It's easy to debug stuff. You can look at what the machine is doing. It's comfortable, effectively. If you flip out of the classic dimension into the snappy dimension, you're back into that very structured, very manageable world. Okay. So the goal is to be faster, because the software is moving faster. The goal is to be easier, because again, if we make it easier for people to share things, then everybody else benefits, right? I mean, I love this about free software, right? It is special to build stuff and publish it for other people to use, right? Not only does it kind of help you, but just think of what it does for all those other people, right? So we wanted to make it faster, we wanted to make it easier, and we wanted to make it much more secure. We also wanted to make it compatible with classic systems. So what I showed you there was I was on a Snappy system, which is connected to snaps in the store effectively, but I could pop into a classic dimension. And it struck us that we could do the other thing as well, right? You could start with a classic system, a deb-based system, a read-write file system, and you could install snaps as well. And I can't demo that now, but it will be in 1604. This idea that, in fact, when people publish these GitHub speed apps, free software apps, those could go to traditional Ubuntu desktop and server and VM cloud systems, just because of the way Snappy's built, right? Since everything is in a box, we can essentially set up a box for it on a classic system just as easily. And so in this way, I think we're really going to help people like the Kubuntu community. We were talking just the other day about how to help communities like that go faster. And one of the challenges for them, of course, is attracting people to this packaging process. But the vast majority of the stuff that people are interested in every day, the new versions of the new stuff, is actually, again, the leaf nodes. It's the apps at the end of the chain, not the sort of libraries at the core. And so this will allow those communities to package that stuff and share it much faster. It also solves another problem we've traditionally had in the Linux world, where our entire software stack was interlocked, right? You got all of the applications from 2014, and we couldn't introduce newer applications because they would introduce newer dependencies. Because of the system of boxes now, the dependencies go in the box, and we're off to the races. So we should be able to bring much newer software to the desktop and to the server, and from a much broader base of developers in this App Store era. So why am I excited about this? Well, first, everything that we do today gets better, right? So PPAs are kind of amazing, but it always freaks me out that I'm giving every single PPA I subscribe to root on my system. They can all change the kernel on my system just by popping a kernel with a higher version number in, and dpackage will very happily install that newer kernel. I might not even notice, right? So as much as I love Google, and I'm intensely grateful for the fact that Chrome is such a fantastic browser on Ubuntu, I'd like to keep that code, and I think Google would appreciate this too. I'd like to keep that code focused on the stuff that we both trust it to be trusted for, right? Because it's enormous. It's an enormous attack vector. So things like third-party software on our existing world go much faster. But this is the other half of that, right? We're about to see an entirely new domain of computing created. We've got personal computing, and that's been getting more and more personal, right? Your phone is the most personal computer we've all ever had, right? And then we've got cloud computing, which is sort of super professional, right? If you think of clouds, they're giant data centers, there are lots of professionals watching them. If something goes wrong there, somebody notices and jumps on it really quickly. But I think about the Linux that's running in that Wi-Fi access point up there that's blinking red. That's kind of awkward that it's blinking red, right? What does that mean? Is it broken, right? If it's broken and someone has to get there, just imagine what that involves. It could be more expensive to reach that box than the box cost in the first place, right? And so in a sense, yay, Linux won, that's running Linux. In another sense, yay, new responsibilities, right? We have to think about building software to support this whole new class of device. Drones. This is a drone from DJI, an amazing company, making great drones. And this is the first drone that they launched with the intended goal. The specific goal was to attract software developers. It's got a little NVIDIA motherboard on it. It's running Ubuntu. And the reason it's running Ubuntu is because all of their research showed that the developers who are doing the amazing computer vision and collision detection and avoidance type algorithms, they're all using Ubuntu, right? They're using the free software stack expressed in Ubuntu. And so maybe something like Snappy enables us to get faster, better apps onto drones. If those are going to be flying up around us, I'd like to know that they can be secure, right? To fix the software on that, I have to wait for the vendor of that device to publish a new version of a single monolithic blob, right? To fix Heartbleed on that device, I have to wait for a vendor who doesn't really have anything to do with the operating system normally. Their focus is on a single application. In a Snappy world, because those are separate blobs, I can update the operating system on there as soon as there's a new blob version of the operating system that comes from the people that I trust to deliver that blob, right? And I can update the autopilot or the whatever else it is as soon as those guys have produced a new version that fixes the issues that they're responsible for. Robotics. This is just, if you haven't been to a robotics fest in the last year, it's just exploding. It's just amazing, right? What is coming out of labs right now will blow your mind, right? We are genuinely at the dawn of a new era. All of that running free software, all of that running Linux, all of that right now completely crazy, right? In the sense of, if you had all of those robots running around in your house and another heartbleed happened, you wouldn't know where to turn, right? Because it would all be compromised, it would all be vulnerable. GE essentially has said that every single appliance they make, from jet engines down to kitchen appliances, will become smart. That means they'll be running Linux. That means they'll be running our stuff, free software stuff. We're going to be responsible for that in an entirely new way. Smart cars, cars that drive themselves, they're all built on free software. And these devices don't have that same property of being either personal, in other words, somebody looks at them every day, or centralized. In other words, they're closely watched 24 hours, 24/7, right? They're sort of just distributed. So we're going to have to figure out how to work with the software on those. And here's where I think the opportunity for people is. This is a town of inventors and scientists and dreamers. So what kinds of things might you dream? Well, there's the hardware, and I think the hardware is going to behave economically like hardware does. It'll be produced very cost effectively somewhere else, right? Almost certainly. But even the guy who's making that hardware is in a super competitive position. In fact, most of the magic here is going to be software. And I assume that just for the core function of that software, I'll have free versions of that software, open source versions of that software, and proprietary versions of that software. And so we need to be able to accommodate that full mix. But in fact, the guy who made the drone only knows about flying that thing around. So I would trust him for the autopilot. Right? But think of all the things you want that thing to do, right? What if I attached a camera to it, and now I could, or a sensor, now I could look at farmland effectively and conduct analysis, right? Well, think of all the sorts of things you can do if you have a moving eye in the sky, traffic analysis if you run a city, the city of Pasadena, nutrient analysis if you run a farm. I love the example of ski resorts that have to find areas where there might be avalanche risk and then drop hand grenades on them, right? I love the idea of an Ubuntu-based drone. I'm going to get that through the TSA. What's that? Oh, that's it's an automated hand grenade dropping machine. Well, come on in, sir. Yeah. Nice clock. All right. So this is what we're trying to set up, right? We're trying to create this framework for people to invent stuff. I believe the vast majority of the fun stuff that gets invented will be built out of free software, and I hope we can help people go faster. So that's the one half of what I wanted to talk about. The other half, what I want to talk about, is on the other end of the spectrum, right? The other thing that's changed in software is we've entered an era of what I call big software. You've heard of big data, right? Think about big software, right? When I grew up, all you needed was a single machine, and you could do all the fun stuff on that single machine. You could get your lamp stack. You could set up all the things that people were talking about. You could be part of the cutting edge just with one machine, right? And essentially, for most people who are passionate about technology, having one machine somewhere, like on the side, was free, cheap, easy, consumable, right? Accessible. The challenge we have now is that the really interesting stuff, like the idea of building an AI in your basement, right, doesn't run on one machine anymore. In fact, it's not even just a few pieces of software. It's big software. This is a phase change. And so again, like the frog in the pot, that's where the temperature is slowly rising, right? We may not be aware of that phase change. So what's happened is that software's gotten bigger and bigger, and the approach that we take to that software, the tooling that we bring to it, the way we think we're going to do it, needs to change to match that. If I said to you, you've got to get 100 tons of H2O from Pasadena to Santa Monica, right? You'd really want to know, am I dealing with ice or am I dealing with steam? All the tools would be different. The mindset would be different. The risks would be different, right? And so in the same way, if I said you're going to install some free software, you'd actually want to know, are you dealing with something that's going to run on one machine effectively, or something that perhaps needs an entirely different way of thinking about that software? So these are some open source projects, some free software projects. They're all pretty amazing. They're all big software, right? OpenStack, Hadoop, TensorFlow. Google just open sourced this very cool deep learning neural network AI-based sort of construct. Cloud Foundry, Kubernetes, Mesos. These are all things people have heard about, but you'd be amazed how few people actually get to play with them, because unlike the software of the 90s, you can't just stick it on a laptop on the side. To really understand it, you have to be able to work with it at scale. It is big software. And the interesting thing here is that the scarcity is no longer the software. Back in the 90s, the scarce thing was the software. It was a miracle that you could get a full TCP IP stack for free, right? Set up web servers. Amazing. What was scarce was the software back then. Now what's scarce actually is the knowledge, the operational knowledge, right? By the time one person comes to understand OpenStack, OpenStack has changed twice, right? And exactly the same thing is true of big data, AI, PaaS, big software. So I've seen super competent teams crushed by big software because they charge in thinking, well, hey, Python on Linux, we've done this before, right? And that's why we've spent so much time and effort building a new way of working with software, a new way of thinking about software at scale. So today's software is about topologies and scale, right? And the operations are really about managing the topology and changes in the topology over time at scale. It's a topology that doesn't sit on 2 machines or 4 machines, it sits on hundreds of machines, and it's the mapping of software to machines and the gluing of all of that together that is scarce, the knowledge of how to do that. So what if we could crowdsource that knowledge in the same way that we crowdsource the code itself, right? When you buy SaaS, right, what are you really buying? If you buy Elastic MapReduce, Hadoop is free. What are you really buying? It's the operations. So what if we could open source operations for big software, right? And what if we could codify all of that so that people could just reuse it in their basement the way we all started reusing Linux packages in the 90s? And that's what Juju is all about. This is a picture. It's a logical picture of a big data deployment, some software. Notice you've no real idea at this stage how many machines that's running on, right? Because what I'm drawing there is a logical description of services spread across some machines. And what matters in this view is just what's connected to what. Each of those boxes comes from a kind of software, a kind of open source software that we call a charm. That's essentially a codification, not of the software, but of how you operate the software, how you get it on, how you get it off, how you connect it to other pieces of software. All of the things that somebody who wants to be like a total expert in that software would need to know, all the stuff you'd find in the book about that software. But instead of reading the book, you can just use these charms. They're open source. And the beauty of this is that when it gets better for everybody at the same time. Now, it's difficult to do this in the same way that it's difficult to create a deb, right? But once it's done, thousands of people can use it without having to dig into the book effectively. And so again, we have exactly that same dynamic of sharing of something that used to be scarce in a form that is easily consumable everywhere. If I want, I can go and have a look at what's actually mapped to which machines. That's obviously super important. And I can do all of this at a CLI or through a REST API. But ultimately, this is what it's about. It's about saying, here is a distilled version of a complex thing that would take you weeks to figure out and set up, and then be too brittle for you to want to touch it. Instead of that, here is a distilled version of that you can use on any cloud or on your laptop effectively, if we can make your laptop look like a cloud. And we can. And the store angle on this is that ultimately that becomes a repository of goodness. It's a repository of competence, not a repository of software, right? We already have repositories of software. It's not a configuration management system either, because inside those charms, whichever communities collaborate on those things, they're using Puppet, they're using Chef, they're doing the configuration management inside those charms. I don't have to worry about it, right? This is a modeling system and a store, effectively, of the knowledge of the free software community for big software, right? So it's an app store, but not for software, for operations. It gives you the SaaS experience with on-premise control. The dark trade at the heart of SaaS is the loss of control of your data, right? And in a sense, that's just as important at scale as it is when we're thinking about software on a device and we want to put it in a box and control it. So what's at the heart of that stuff? It's code. And code, what we've learned in the last What we've learned over the last couple of years of doing this is that the unit of collaboration here is not actually around a single piece of software. It's about common aspects of operations. So here's an example. Here are two charms talking to each other, and they're actually made out of reused operational code. So for example, there's a chunk of operational code called a layer that would handle setting up a JVM, right? And in fact, you could reuse that in any charm that was a charm of Java software. On the other side, you might have a layer that was used for setting up Python code, right? And all of the common operational practices that would go with that. Similarly for key generation and so on. But there's a shared layer there, which is specifically around the protocol that those two pieces of software are going to talk. And there's now a rapidly growing community of people contributing this operational code, largely in Python. It doesn't have to be, but largely in Python effectively. Okay. So I want to wrap up with just one teaser trailer of something new in 1604, which comes out in April. And that is something called LexD. Now, if you haven't played with LexD is essentially LexC 2.0. It's a hypervisor, gives you virtual machines on your laptop that are Linux only, but super, super fast. So they're Linux only because, in fact, those virtual machines are containers, but there's been an enormous amount of work to make them look, feel, and act just like virtual machines. So you can get a CentOS one, you can get a Debian one, you can get an Ubuntu one, and off you go. Super fast, super light. I think that is the single tool that is most going to change what people do with their Linux laptops, because it's going to allow everybody to work with big software in a very realistic way, because you can actually have 50 machines running on your laptop on an airplane, right? Whereas today, there's very few people that actually get to work with 50 machines all day long and develop code, right? The coders tend to have far fewer machines available to them than the ops guys. So if you haven't looked at it, that is the single thing that I am most excited about for everyday developer usage in 1604. The nature of software is changing. The nature of our communities will change to match it. But it's been a real pleasure to be here at SCaLE, because more than almost any other conference, this feels like one where it's smart people coming together to figure stuff out without much of an agenda. I hope this stimulates debate, thought, discussion, and I hope some of what I've showed you is super useful to you all in the years ahead. Thank you very much.
Can I get there we go. So thank you very much, Mark. I've got George Castro in the audience here with a mic. If folks have questions for Mark, just kind of raise your hand, and George will come find you with a mic. And while he's doing that, I've also got something here for Mark. So thank you for joining us today and for being a member of the team. And so we'd like to offer you this jersey. Cool.
Can't believe it took me 14 SCaLEs to get one of these. I finally made the team.
Thanks.
Hey, so I have a question about LXD. You spoke about it and you described it as a hypervisor, but you also said that it's an extension of LXC. Is this truly a system which allows, different kernels to run within it? Is it truly a hypervisor?
No, so it is a hypervisor in the sense of providing sliced machines, right? It's a container system in the sense that all of those use the same kernel, right? The key transition that I expect to happen in the next couple of years is when the silicon, the chip, the CPU, guarantees the isolation of containers, which we don't yet have. But all of the major silicon vendors have expressed that that's on the roadmap. And so at that point, you would have the same isolation guarantees. You can't run Windows in a container, but I think you'll see the LXD API on Windows to get Windows containers on Windows. So the LXD API gives you a single REST API to talk to a machine to say, give me a slice of yourself with this effectively guest OS. You'd have to talk to Windows to get Windows guests. You'd have to talk to Linux to get Linux guests, but you could get them both.
So, Mark, I live in the AWS world, and in the AWS world, we use Ubuntu a lot, but it's sort of a second-class citizen. Do you think there's any possibility of that changing?
So when you say second-class citizen, you mean relative to Amazon Linux?
Yes.
Yeah. So actually, I like the fact that the clouds have teams that work on their own branded Linux on the cloud. I know that large users of those clouds have good reasons, essentially, not to use those because that would be tremendous lock-in. But in fact, I think there's a positive side to the work that those teams do. Remember, they see the other half of their infrastructure in a way that we never can. And so, for example, Google does this as well. They have teams that are essentially trying to figure out how to make the guest go faster, how to make the guest more efficient. And what they do is they figure stuff out in a place where they can go really fast, where they don't have to ask anybody's permission or no one else is going to care effectively. So they figure stuff out and then they tell us, and hopefully we're really good at taking what they've learned and moving that into Ubuntu. The Ubuntu that you get on each different cloud is tuned for that cloud because of that process. And genuinely, they're in a better position to lead that process for their cloud than we are. So I'm glad they did it. They do it, and I think you shouldn't feel of Ubuntu as a second-class citizen on any of those clouds. It's we have great relationships with them, and they feed us a lot of information, and there's good quid pro quo in that.
Really, the tool set on AWS Linux is more developed than it is on. The tool set on AWS Linux is more developed than it is on their Ubuntu and.
You mean the
CentOS.
AWS tools?
Right.
Right. Yes. Well, that's good feedback. Thank you.
So we've got time for just one more question, maybe two, but let's see how this goes.
So one of the concerns that I've had for quite a while in open source is that we continue to abstract away the lower level. And then in a lot of ways, that's a really good thing. We've abstracted away the kernel with HAL and dbus. It makes it a whole lot easier to interface with devices on the system. Now we're abstracting away configuration of servers and services that such as MySQL, MariaDB, and that's also a great thing for operations. But we have to hand off everything that we're developing to our children. And are we about to create a world where we have children who are never taught to develop on the kernel because there are no kernel developers anymore?
Our children
can't develop at the low level.
Our children aren't going to write software. Machines will write software for them, for sure.
So my question is, and I hope it's not a dumb question, but has container technology made cloud platforms that run on hypervisors such as Zen and KVM, has it made them obsolete effectively because of the performance benefits?
No. What we expect is that you'll get clouds where you can get either or and both. Containers and VMs. Today, there are still reasons in a public cloud for you to want to be inside a hypervisor, inside a virtual machine. Reasons for both sides, right? For the cloud host and for the cloud guest. In a private cloud case, that's much less clear, right? In a private cloud, the main reason that we see as containers mature to keep VMs is to the question earlier, for alternative operating systems, where if you want to run something that's QNX or something that's on DOS or something that's written for Windows on a Linux host, you couldn't do that in a container. This will be a graceful transition. All I would encourage is that you really exercise LXD on your own laptop so that you feel comfortable with it, using it in places where it's useful for you. Certainly useful also for getting more out of the VMs that you buy on the cloud, because you can slice them up, and so you can be more confident stuffing more software into the VM and keeping that software somewhat isolated from itself for management purposes. One of the cool things that LXD got over Lexi was the ability to guarantee quality of service, right? To do CPU pinning or to guarantee a certain amount of time or RAM or I/O effectively to a container. So starting to gain all the primitives that you'd associate with a hypervisor. Ilan.
Great. Well, thank you very much. Again, Mark, if folks have more questions for Mark, I'm maybe
I'm around all day.
He's around all day, and maybe you can catch him in the hall here. Thanks. So a couple quick notes about the program for the rest of the day. First, wanted to thank you all for being members of the SCaLE community. It's been 14 years that we've gotten to get together with you guys and have our large reunion with our closest friends and family from the open source community, just all 3,000 plus of you. So thanks for coming out every year. As you know, I have a couple traditions each year at SCaLE. The first is we're running Weakest Geek tonight in this room at 7 p.m. And you've got some great contestants that'll be on stage here and for some comedy gold. After that, we've got the SCaLE's Game Night, which will be just behind me here in Ballroom's INJ. And so you'll have a great time to play with board games, video games, and lots of other great surprises. And then one last administrative note, we have 2 talks that switched on the schedule, so please keep an eye on Guidebook. Dan from VictorOps will be going in the 11 a.m. slot. 11:30 slot. So again, thank you everybody for coming out. We're looking forward to seeing you tonight. Please, if you see a SCaLE staff member wearing one of the yellow shirts or the Star Trek-y black shirts, please thank them. Those are your AV and tech crews here at SCaLE.